Hi guys, welcome back. So this is a continuation video for chapter 2, practicing hacker tools part 1.2. So if you guys missed this chapter 1, there are 4 videos you guys can go and watch to get better understand. Okay, so let's continue our chapter 2. Powercat. Powercat is essential that Powershell version of Netcat. It is a script we can download to your Windows host, which is simplify the creation of bind and reversal. So let me show you that how to download the Powercat. So now you guys can see here. So the first link, in the search, the Google search result, the first one is the correct source of for downloading Powercat. So you guys can get download from GitHub. So the author you can see here. Okay. So you can just download like this. So the file has downloaded. So let's open. Let me show you this. So this is a file. So I have. Okay, this is a Powercat shell, the script. Okay, so let's open the PowerShell. Okay, so now we're going to use the import module. Import module, sorry for that. So the import module command lets adds one or more modules to the current session. Okay, so so we have now successfully imported the module. Now it is worth noting that scripts loaded in this way will only be available in the current PowerShell instance and will need to be reloaded each time we restart PowerShell. Okay, now that our script is loaded, so we can execute Powercat as follows. Okay, so we can view the help menu by pausing the -H options or -H options to Powercat. Okay, so Powercat seems to be operating correctly. So let's find out what we can do with it. Okay, Powercat file transfers. Let's take a look at how to use Powercat to transfer from Tom to Peter as a way to demonstrate file transfers. First, we run a Netcat listener on Peter's computer. Okay, so we named it the file name and then enter. Use the password, the root password. So next we will invoke Powercat on Tom's computer. The -C option specify the client mode, and we provide it with the remote IP address and port to connect to. Okay, -P. So we then use the -I. So we then use the -I options and indicate the local file that will be transferred to the remote listener. So we can just enter now, and then here you guys can see finally Peter machines, the Linux machines, finally the Peter will kill the Netcat process and check that file has been received. Okay, let's see now. So you guys can see here the incoming dash Powercat. So great, our file was transferred successfully. Powercat Reversal. The reversal process is similar to what we have already seen. So we can just begin with the your Netcat listener on Peter's machine. Okay. So we can begin with the Netcat listeners on Peter's machines. Just enter the password of root password. Next, Tom will use Powercat to send a reversal. So let's open the Windows machine. Control C. So now let's enter the command, the Powercat command. Zero dot 128, sorry, 108. So this is a Linux IP address. Then port number 443 -E is execute mode. Command.exe. In this example, the -E option specifies the application to execute once a connection is made to the listening port. So after hitting enter Peter's Netcat, so let's enter, and we can see the Peter's computer, the Linux machine. Sorry, ipconfig. So you guys can see here the IP address of Windows machine, right? So you can also check here. As expected, we received a reversal with Powercat. Powercat bind shells. We can also use Powercat to start a bind shell on Tom's computer. So Control C. So let's enter the Powercat -L -P 443 -ecmd.exe. So we will use the -L option to create a listener and -P to specify the listening port number. We use the familiar -E options to execute command.exe once connected. Finally, Peter will create a Netcat connection to bind shell on Tom's computer. Okay, for that, so 128, there's a Windows Tom's computer's IP address, and then port number. Just enter. Use the root password. So we can now enter. Click allow access options here. So now we can see here. So let's check this IP address or host name. So you guys can see. Excellent. We have yet another alternative to standard Netcat shells. So press Ctrl C, clear. Then Windows machines, Control C. It's clear. So Powercat standalone payloads. Powercat can also generate standalone payloads. In the context of Powercat, a payload is a set of PowerShell instructions as well as the portion of the Powercat script itself that only includes a feature requested by the user. Let's experiment with the payloads in the next example. So we will begin by starting a Netcat listener on this Peter's machines on port 443. Now we will create a standalone reversal payload with the Powercat. Just enter here reverse shell. So the syntax is the same as a reversals, but we add the -G option to tell the Powercat we want to generate a payload and redirect the output to a file. So this will produce a power script. So let's enter let's execute this command here. So now we guys can see on the Peter's computer. So now we can check the reversal scripts. So here you guys can see. So let's execute here. Sorry. Let's execute reversal. Okay. So now you guys can see here. So this will produce a this will produce a PowerShell script that Tom can execute on his machines. Okay. So it is worth noting that standalone payloads like this one might easily detected by IDS, intrusion detection system. Okay. We can attempt to overcome this problem by making use of PowerShell's ability to execute base64 encoded commands. So Control Z. Okay. So to generate a standalone encoded payload, we are just going to modify the same command. Okay. Just use -E, -GE, just adding the E options, and then here encoded reversal. So we use the -GE options and once again redirecting the output to a file. The file will contain an encoded string that can be executed using the PowerShell -E options. However, since these options was designed as a way to submit complex command on the command line, the resulting script cannot be executed in the same way as our unencoded payload. So let's execute. So instead, Tom needs to pass the whole encoded string to PowerShell -E. So let's copy all these to the clipboard. So we will return to PowerShell to execute our reversal. So let's clear this. Okay, with -E. So we run PowerShell.exe with the -E options and paste the encoded reversal. So now let's hit the enter button to execute it. Okay, so now you can go back to the Peter's computers. Peter's received the reversals on his waiting list there, right? So you can see IP config, yeah. So excellent, this is another great tool in our arsenal. So Control C. So we have covered a variety of tools that can handle file transfer, bind shells and reversals. These tools have verifying features, strengths, weakness and applicability during a penetration test. Wireshark. A competent penetration tester should be well versed in networking fundamentals. A network sniffer like Wireshark is a must-have tool for learning network protocol, analyzing network traffic, and debugging network services. Wireshark Basics. While analyzing network traffic with a sniffer, it is easy to get overwhelmed by the amount of noise in the collected data. In order to facilitate the analysis, we can apply capture filters and display filters within Wireshark. The secret to using any network sniffers include Wireshark is learning how to use capture and display the filters to strip out superfluous data. So let's open the Wireshark on the Kali machines. Sudo Wireshark. Okay. Capture filters. When Wireshark loads, we're presented with a basic window where we can select the network interface we want to monitor, as well as set display and capture filter. We can use captured filter to reduce the amount of capture traffic and narrow our focus to the packets we wish to analyze. We will start by selecting the interface we would like to monitor, and we will enter a capture filter to our subnet. In this case, we can use the net filter to only capture traffic within a specified address range. Okay. With the capture filter set, we can start the capture by double clicking our Wi-Fi. So I'm using this Ethernet 0. So it will show the available interface. Okay. Display filters. Now that Wireshark is capturing all the traffic on our local network, we can log into on FTP server and inspect the traffic. So let's go this clear, connect the FTP. So FTP is a Windows server. So I'm going to use the password. Okay. So quit and then exit. To further narrow down the background traffic, let's make use of a display filters to focus only on FTP protocol. So now let's apply a display filter that will only FTP data or TCP traffic on port 21. So for that, TCP, so let's say the port number 21. Okay, here you guys can see the IP address, the source IP address and destination IP address. So where the FTP server, right? So the password is records everything. So if you guys want to see the password, exact password like this, you can use this command, ftp request dot command equal to user, and then ftp request command dot password. So it just enter. So you guys can see here the password, the real password, and then FTP everything. Okay. So this filter worked very well. Now we can clearly see only FTP traffic on port 21. Following TCP streams. Wiresharks allow us to view network traffic including the content of each packet. However, we are often more interested in streams of data between various applications. We can make use of Wireshark ability to resemble a specific sessions and display it in various format to view a particular TCP streams. We can just right click the FTP. So whatever the IP address you guys can see here, so the FTP protocol, right click and then follow and TCP stream. So now you guys can see what I showed earlier, the username, password, whatever you have typed, the text you typed on the FTP in the terminal, right? So you guys can see here. It's okay. So in order to close this stream, we just close this cross button, so it will back to the all streaming IP address you guys can see here. So let's close it. TCP dump. TCP dump is a text-based network sniffer and is by far the most commonly used command line packet analyzer. It can be found on most Unix and Linux operating system. TCP dump can both capture traffic from the network and read existing capture file. So let's look at what happened in a PCAP file which was captured on my test environment during the FTP communications. So let's enter sudo -r ftp.pcap. First we will launch TCP dump with a sudo and open the file with the -r option. So let's enter. So now you guys can see here the IP address, a source IP address and destination IP address, and then port number. So in the protocol UDP or TCP, so everything you guys can find here. Filtering traffic. The output is a bit overwhelming at first. So let's try to get a better understanding of the IP address and ports involved by using awk and sort. So using the same, I'm going to add the extra stuff, -n, and then pipe awk-f, capital F, then print $3, then pipe sort and unique -c and head. First we will use the TCP dump -n option to skip DNS name lookups and -r to read from our packet capture file. Okay. Then we can pipe the output into awk, printing the destination IP address and port contained in the third field, and pipe it again to sort and unique -c to sort and count the number of times the field appears in the capture respectively. Lastly, we use head to only display the first 10 line of output. So let's enter. So now you guys can see the IP address. So we can see that IP address 192.168.0.108 was the most common destination address, followed by the 192.168.0.128. Given that, okay, so the port 21 we can see here the FTP port number. So we can use the filters to inspect the traffic more closely. In order to filter from the command line, we will use source host to output only traffic originating from a given host. We can also apply a destination host filter. In order to filter from the command line, we will use source host to the output only traffic originating from a given host. So you guys can see here the source IP address, SRC, host, and then source IP address, and then the -R option is a read the logs, so we can just try this command. So you guys can see now the source IP address, so and the destination IP address. So this FTP captured, this is a small size of captured file. So you can also use this destination. We can also apply a destination host filter to output any traffic destinated for a specific host, or we can filter traffic. Okay. So, or we can also use this. We can also filter traffic by port number. So this can done by the specifying port followed by the port number. So which is our case 21. So there is a other option. You can also filters using the operator command like AND gate, OR gate, or NOT gate, so something like that. So let me show you that. TCP dump, source IP address, and AND gate. First let me check TCP dump with the port number 21. So now you guys can see. So you guys can check both IP address as well as the port number. So if you want to filter the specific IP address and the specific port number, so you guys can use this command, the source IP address and TCP port 21. So this is a small example to give you a clear idea. So let's clear. So now we can use the NOT gate. We can also use these two operator on the same with the same command. So and NOT, TCP port 21, destination port. So something like that. So source port, destination IP address and destination port, and source IP address and destination port. So there's a combination. So whatever you want to use on your environment. So this type of command is really helpful when you're stuck at some point. So enter. So yeah. Okay. Now let's say by default the TCP dump capture only the package header. However, sometime you may need to inspect the content of the packets. So TCP dumps allow you to print the content of packet in ASCII and hex format. So first let's see dash capital A. What the dash capital A do? Okay, dash A. So here the dash capital A tells TCP dump to print each packet in ASCII. Okay, in ASCII format. Let's enter and see the result. So now you guys can see the result, everything in the ASCII format. Okay. So you can see the quick what I entered the text line during the FTP. So everything you guys can find here in the ASCII format. So now let's see in the -x in the hex format, -x. So this X, when you use $X, it shows both format, ASCII and hex format. Okay, so now you guys can see here. So the good boy command you can see here. Okay, that's it guys for this video. So upcoming videos we will see that network mapper nmap. So it's all about the nmap for next video. So please don't miss this next videos, and if you guys missed this previous video, please go and watch this previous video and support me. Please subscribe my channel, press the bell button to get more update, share the video to your friends guys. See you, bye bye.